Okay, Math 2, Unit 6, similar figures. So number 1, what are similar figures? They are two or more shapes that have congruent, and that's the congruent symbol. I'll write that in. Congruent angles and proportional, and I have no idea how to spell proportional, but sides. All right, so similar figures are two or more shapes that have congruent angles and proportional sides. And as we talk more about that, I think it'll make a little bit more sense. Number 2, what is a similarity ratio? It's like a dilation. Like a dilation, it's the proportion relating the sides of the two similar figures. And figures is probably a better word than shapes, so I'm going to go over here and cross out the word shapes and put figures. So similarity ratio is like a dilation. It's the proportion relating the two sides, relating the sides of the similar figures. And really, it could be two or more. All right, number 3, how do we mark two sides congruent? If we have two different shapes, we'll just say that we have these two lines. How would we mark them as congruent? And congruent means equal. That means the same. We put a little tally mark on it. That blue tally mark means that they're equal. Now, if we had another two shapes or two lines, and we wanted to say the blue lines are congruent and they are not congruent to the orange, we'd put more than one tally mark. We could put two tally marks on both of them, right? If we had more lines, we could have 3 tally marks or 4 tally marks. Number 4, how do we mark two angles as congruent? Well, say we've got these two angles. Here's our two angles. If we put a little swoop in there and a swoop in there, that means those two are congruent. It's kind of like a tally mark inside the angle. Now say, just like how last time I said, well, what if we have two different angles and we want to say that they are congruent, but they are not congruent to the other ones? Well, we would put 2 swoops, or you could put 3 swoops or 4 swoops. I've seen some people also decide to put little tally marks like this in there. Tally mark like that. You're welcome to do that. It just has to be the same exact, it has to be the same for both of them. So if I do a tally mark there, I have to do a tally mark there also. All right, that's how you mark angles congruent. Now, how do we show that two sides are parallel or that two lines are parallel? Well, if we have two lines, we'll put little arrows on the ends of our lines. To say these are parallel, and parallel means that they do not ever touch, ever. We would put little arrows on them. Now, say we have two other lines, and we want to say that the two lines on the right, or let me change their color. The green lines are parallel, but they are not parallel to the orange. We're just going to put 2 little arrows. Oops. We'll put 2 little arrows. 1, 2, 1, 2. And those arrows would mean that they are parallel. All right. Now to get to the actual problems. Number 6, state if the polygons are similar. Now, if we look at the number 1, the definition, 2 or more figures that have congruent angles and proportional sides. So we have 2 things to check. First off, we'll check angles. Are all the angles in number 6 congruent? And this one's actually kind of a not an awesome example to start with because they're all right angles. on both figures. So yes, the angles are all congruent. Now we want to see, are they proportional? We want to see, are the sides proportional? So what we want to do is we want to pick, we've got the 45 and the 45, and we would think that those would correspond with the 9 and the 9. So we're going to make a proportion, and a proportion is a fancy word for a fraction. So we're going to say 9 over 45, and we want to know, is that equal to 7 over 35? Now this one's kind of nice with the rectangles because we really only have two sides to check, because each rectangle, two of the sides are congruent. So we really only have to like check the width and the height. On the next one, on those trapezoids, we can see that there's three different kinds of angles. So, but once we get to here, you could do this a couple of different ways. We just want to see, are they congruent? Are they equal? Are those two fractions equal? So one of the easiest ways is to just take 9 divided by 45, and we get 0.2, and then we can do 7 divided by 35, and we get 0.2. Okay, you could reduce the fractions and see if they're equal, but this is just a really quick way to do it. You take the top divided by the bottom and convert it to a decimal. So those are equal, so they are proportional, so yes, it is similar. All right, number 7. So this one's a little bit better of an example for the angles. We want to check, are the corresponding angles congruent? So we look here, we've got this bottom left, bottom right, bottom right, upper left, and upper right. They all correspond and are congruent, right? Do you kind of see what I mean? I could move the shape and blow it up and the angles would be the same. So the angles are congruent. So there, we've checked that. Now we need to check proportional, or I'll just put sides. So I'm going to take each piece. So 4 and 14, those would go together. I'm going to say, well, 4 over 14. And I want to know, is that equal to, let me change back to the blue color. I want to see, is that equal to 5.1 over 22.9? And that also incorporates this 5.1 and this 22.9 also. And then lastly, we've got 8 over 32. Now this one, we have 3 different fractions, and we need to check that all 3 of them are equal. So let's take 4 divided by 14, and we get 0.2, I'll just put 29. And we want to know, is that equal to 5.1 divided by 22.9? That's 0.22. They are not equal. And you could continue and get that 8 divided by 32, but if you know that 2 of the proportions are not equal, it doesn't matter if the other one is. We know that it is not similar. And that's our answer. All right, let's continue on the back side. Now this one here is a little bit different because we can tell that they rotated the trapezoids. We could kind of see, though, that this and this would go together, right? This guy and this guy would go together, and then the two 15s would go with the 22.5. Can we kind of see how this would rotate over? So let's check the angles. We've got 2 angles that are congruent here, and we have 2 angles there. They're on the long side here, and they're on the long side there. Next up, we look at the double tally marked angles, and we've got 2 double tally mark angles there, and they're on the short sides. So our angles are good, and on a lot of these, the angles will be good. Now for the proportions, we'll take, well here, we'll do our short side first. So our short side on the right one is 25. Our short side on the left one is 30. Our long side on the right is 35, and our long side on the left is 42. And then the side left over is 12.5 and 15. So now we need to divide these. We get, if you divide 25 divided by 30, you get 0.83 repeating. And then you get another 0.83 repeating whenever you divide 35 divided by 42. And when you divide 12.5 over 15, you get 0.85 repeating, 83, excuse me, repeating. So this means, yes, similar. All right, number 9. Now, something fancy here is that they did switch their sides. So what's really good whenever you're dealing with, what are these called? Rectangles, is take the short side on one of them and match it up with the short side on the other one. I know that you guys probably don't have highlighters and all that stuff, so I think it's sometimes useful to do different shapes. Like I could do a triangle around this one and I could do a box around this one. That helps me sometimes if I don't have a highlighter. So we're going to have 8 over 28, and we want to know, is that equal to 14 over 49? I can divide those and I get 0.286, and that is equal to 0.286 again. Now I didn't even check my angles because if you look here, they're all right angles. So yes, similar. All right, number 10. The directions say the polynomials in each pair are similar, so you don't have to check. Find the scale factor for the smaller one to the larger one. All right, so whenever you're just looking for the scale factor, you just want to pick two sides that line up. So on here, here's the point, here's the long point. And then we've got this one and this one. You kind of just have to think about it and kind of flip it around in your head and see how they would line up. So you have to pick two sides that are labeled in both of the pictures. I'm going to pick the 3 and the 18. So the answer is 3 over 18, and we can reduce that to 1 over 6. Now, whenever we do a scale factor, we normally write it as a ratio. So we're going to write 1.6. And this means the same thing as that fraction. It's just written in a little bit different way. Now, something important here. It says find the scale factor of the smaller to the larger. That means the smaller number needs to go first in your fraction, or in your what is this called? What did I call it? A ratio. All right, number 11. Again, you've got to kind of flip it around in your head, and I'm going to say, well, this is kind of pointy. It could be going with maybe this one. We could kind of think about if this rotated over, it would go that way. So we could say that the 20 goes with the 8. Actually, can we say that? We could say the 20 goes with the 8, or we could say the 15 goes with the... All right, sorry, I got a phone call there. So we take this edge here, and we could rotate it up. We would see that it would go there. We already said that the highlighted 8 and the highlighted 20 could go together, and the 6 and the 15 could go together. And you really only need to do one of these, but I want to do both of them just so that we can see that they do give us the same answer. We have 6 over 15 and 8 over 20. We reduce these. Let's look back up at that 6 over 15. We could pull a 3 out of those, and we get 2 over 5. The 8 over 20, I'm going to divide those by 2. We get 4 over 10, and we could reduce that again and get 2 over 5. So we got the same thing here and here. Now the last thing is to write it as a ratio, 2 to 5, just like that. All right, number 12. Solve for x. The polygons in each pair are similar. Now, this is a little bit unique. We know the 15 and the 3x plus 2 would go together. The 18 and the 24 would go together. So let's write our proportions here. 15 over 3x plus 2. and 18 over 24. Make sure the top numbers come from the same shape and the bottom numbers come from the same shape. The bottom numbers came from this guy, the top numbers came from this guy. Now it's just solving. I'm going to multiply, or what is this, the butterfly method, whatever you want to call it. I'm going to multiply by 3x plus 2 on both sides. So I get 15 equals 18 over 24 times 3x plus 2. I'll multiply by 24 before I distribute there, and I get, what is 24 times 15? 24 times 15 is 360 equals 18 times 3x plus 2. I'll distribute and I get 360 equals, well, 18 times 3 is 54x, and then 18 times 2 is 36. I'll take 360 minus 36, and that gives me 324 equals 54. Actually, yeah, it is 324. 54x. I'll divide by 54, and I get x equals 6. That's our answer. Number 13, we need to start off by taking this 3x minus 3, and we need to find what it could go with. I think it would go with the 12. And then the 24s could go with the 16s. And you really only need to grab one of them. So we'll start off with 3x minus 3 over 12. And then again, we're going to return to the same shape, right? We started with the 3x. We started with this shape. We have to start with this shape again. So we're going to do 24 over 16. I'll multiply by 12, and I get 3x minus 3 equals, I'm going to do 24 times 12 divided by 16, and I get 18. Right there, what I did was 24 times 12 over 16, and I typed that in my calculator. I'll add 3, and I get 3x equals 21. And 21 divided by 3, x is 7. All right, there we are. That's number 13.